Naming acids. So acids are a special category of molecular compounds. Acids are molecular compounds, but they're ones that form ions when they're dissolved in water. Most molecular compounds do not form ions, even when they're dissolved in water. So ionic, I don't know what I'm saying. Acids, that's what I'm trying to say. Acids are kind of different. How do you recognize an acid? It starts with hydrogen. So hydrogen's the first element in the formula, and then it's followed by one or more nonmetals. There's no metals in these. So we can put these into two groups, and these groups are important because the naming rules are different for each of them. There are binary acids. So these have hydrogen and nonmetals, and oxyacids. This has hydrogen, a nonmetal, and oxygen. So oxyacid, it's got oxygen in it. So acids start with hydrogen, H. The oxyacids have oxygen in them. The binary acids are the others. Different set of rules to name both, to name each, I mean. So binary acids. The pattern for these is a prefix hydro, and then you take the name of the nonmetal, whatever it is, and you change the ending of its name to ic, and then you put the word acid on the end. So HCl, in the parentheses with the AQ, that stands for aqueous. It means it's dissolved in water. So HCl starts with hydrogen, so we know it's an acid. It doesn't have any oxygen in it, so we're going to use the binary acid rules. So we look at the Cl, so this is chlorine. So we change chlorine to chloric, and we put the prefix hydro in front. So hydrochloric acid. HBr is hydrobromic acid. Okay? So what would this be? HF. Hydrofluoric acid. Hydrofluoric acid. Fluorine is one of the element names that's misspelled a lot. It's UORINE. The common misspelling is like this. It's not fluorine. That's flour, right? You make cookies out of that. Fluorine is gluten-free. There's no wheat flour in fluorine. There's no flour in fluorine. So if you write it and you see flour, switch the vowels. I won't try to trick you with this one on a test or anything, but I do want you to try to spell it right, okay, because it looks dumb. What about this one? H2SE. Hydro. So Se is selenium, and we need to take the ending off and make it ic. So hydroselenic acid.
Does it stay the same even though there's two hydrogens?
Yeah, it does stay the same even though there's two hydrogens. So an acid is a molecular compound, but when it's dissolved in water, it forms ions. What ion does selenium form? What charge does it have? -2. And what is the charge on a hydrogen ion? +1. How many hydrogen ions do we need to balance the charge on the selenium 2-? We need 2. So that's why it's H2S. Because we can understand that and predict it from the charges that the ions that form have, then we don't need to specify it in the formula. In the name. We don't need to say dihydroselenic acid. Okay? That's an excellent question. Any other questions?
These are binary?
Binary. Not oxyacids. So let's look at the oxyacids. Oxyacids have oxygen. They contain oxyanions. So we look at these. These are 3 oxyacids. They start with H. That's what tells us it's an acid. So cover up the H and look at what's left. What does that look like? NO3. That's our new friend, nitrate ion. So when this dissolves in water, it forms the nitrate ion and a hydrogen ion. And so the name is based on the name of the anion. H2SO3. We'll cover up the H's. SO3, that's the sulfite ion. Sulfite has a 2- charge. That's why this acid has 2 hydrogens. H2SO4, cover up the H's. SO4, that's sulfate ion. It has 2 hydrogens because the sulfate ion has a 2- charge. In the formula for a compound, whether it's ionic, molecular, or an acid, we do not write the charges over here. It would get very, very cluttered, and it's not necessary. So we only want to write the things that we need. The number of hydrogen ions depends on the charge. So here with the 2- charges, it's got 2 hydrogens. 1- charge, it's got 1 hydrogen. Okay? So the names of these are based on the names of the oxyanions. So you take the base name of the oxyanion. If it ends in "ite," you change "ite" to "us" and add the word acid. There's no hydro in front of these. If the oxyanion name ends in "ate," you change the ending to "ic" and put the word acid on there. Do I have that written out anywhere? I don't. I'll have to write it by hand. So that's another one of several places where we have 2 things that correlate and we have to remember how they go together. I hate stuff like that. So you got to find a way to remember it. Oh, gosh. So Rick ate him before he could bite us. So that's a silly sentence. Let your imagination go wild and come up with a scenario where you might say that. Rick ate him before he could bite us. How does that help? Ick and ate go together. Ite and us go together. So if it ends in ite, we change it to us. Those 2 go together. Ate goes with ick. There's another one, the white mouse ate icky cheese. Whichever one you like. Okay, so that's how you connect those 2. So here are some common oxyacids, their names, and the oxyanions. So HNO2, if we cover up the hydrogen, NO2 is nitrite. We change ite to us. Rick ate him before he could bite us. Ite us. So nitrite becomes nitrous acid. HNO3 has nitrate ion in it. We change the ate to ic, and this is nitric acid. H2SO3, SO3 is sulfite. That becomes sulfurous acid. Now the UR from the sulfur name comes back. Why? I'm not really sure. Maybe because sulfus sounds funny and sulfurous sounds better. I don't know. There's probably some historical meaning. I'm not going to try to trick you about that. If you said sulfus acid, I'm like, good enough. Sulfate becomes sulfuric acid. Sulfic acid also sounds kind of stupid. Chlorite, chlorous acid, chlorate, chloric acid, acetate. Okay, that's kind of an odd oxyanion. It didn't follow those patterns with the ite and the ate. You just have to memorize that one, and it's the only one of its kind. But you can still follow this pattern with the acids. Acetate, you take off the ate and change it to ic, and that's acetic acid. That is the active ingredient in vinegar that gives it its distinctive smell. Carbonate, carbonic acid. Any questions? So the prefix hydro means it's a binary acid, no oxygen in there. If it doesn't have hydro, then it's going to be an oxyacid. So let's name this one HNO2. So what we need to do is identify the oxyanion and name that. What's the name of that one? Well, it's either nitrate or nitrite, right? This is nitrite. So to make the acid, we change the ite ending to us. Nitrous acid. Any questions? How about this one? HClO4. Well, take off the hydrogens and write what we have there. just ClO4 minus. What's the name of that ion? Chlorate is ClO3 minus. This has an extra oxygen. Perchlorate. So this is perchlorate ion. So we change ate to ic. Leave the per on there. So changing the ate to ic, we get perchloric acid. Any questions?
And that one you use going back to like the prefix, where did you get the per?
I got the per because chlorate is ClO3 minus. And this has one extra oxygen. So to name this oxyanion, we put a prefix on that says more. This has an extra oxygen. Okay? Any other questions? There's not nearly as many acids that we can give you as examples as there are ionic compounds. There's gazillion ionic compounds. I counted them last night. There's a gazillion.